Hello, and welcome to Introduction to Software-Defined Radio with a focus on aviation frequency applications. I'm your speaker, David Horvath, KB3RIJ. This is my contact information, should you care to use it, and the background on this presentation. Hopefully you've already seen this. I'm not going to spend any time on this screen. Quick background, I'm an IT professional, worked on various platforms since the 80s and a variety of tools, and have presented workshops on various topics, many places around the world, including US, Canada, Oxford, England, Australia, France, etc. My undergraduate degree is Computer and Information Sciences, and I have a master's in Organizational Dynamics. Most of my career has been consulting, and recently I've been in-house, currently doing data analytics, engineering, or wrangling at a regional bank. I've written several computer books, non-radio related, and I've been an adjunct instructor covering IT topics. I had a third-class radio telephone in high school, and got my technician in general on the same day in 2008. Software-defined radios simply apply DSP, digital signal processing techniques, to incoming signals. They come in all shapes, forms, and price levels. And it was first created in 1982 at RCA using the Cosmac CDP 1802 chip, a version of which is actually on the Voyager Explorers. The inexpensive day of USB SDR began with the DVB-T, digital video broadcast terrestrial, in Europe. And it typically includes a Realtek RTL 2832U controller and a tuner like the Rafael Micro R820T. And you can get these on Amazon for $22, including an antenna and a remote. Newelec has a variety of popular USB SDR from about $30, and these are upgrades from the basics. They sell as fancy as the Hack RF SDR and SDX transmitter for around $350. And SDRs are being included in HF transceivers like the ICOM 7610 or others in the $2,000 to $4,000 range. So you have a choice. You can go inexpensive, you can go very expensive. So some examples. We have the European DVB-Ts, and that's the package that you get. You get a little antenna, a little remote, and the actual SDR. And that's about the size of your thumb. You have the Newelec Nanos. This one is a Nano 2 Plus. They tend to get hot. The Nano 2 Plus is about the size of a large postage stamp. The Nano 3 is similar. USB socket on one side. You can't see it in this picture, but there's an antenna connection on the back side. This one has a 90-degree adapter on it. And the Nano 3s are actually aluminum so that they dissipate heat better. And of course, the Hack RF1, that's about the size of a book. A lot more capabilities. You have the ICOM 7610, which of course is boat anchor size, and the Flex 6400, which is pure SDR. Software-defined radios have a 3 megahertz to 7 megahertz of bandwidth. And what does your home ham radio have? 3.5 kilohertz? Yeah. And often tuning capability from 10 kilohertz to 3 gigahertz. And even those that, if you want to go lower, you can always put a PAN adapter on. They do require computing power to convert the signal to usable information. And it's relatively easy to connect to the internet for sharing because they are producing digital data. They can be connected to a variety of computing equipment, your PC, Mac, Raspberry Pi. I've connected them to tablets, cell phones, so that I can use an SDR in an airplane when I'm a passenger. You can share receive signals in analog or digital form, right? You can process them into sound, or you can grab data being sent over the air. And you can listen to unexpected sources like aircraft, and I'll be talking about that more, or even your tire pressure monitors. You have the capability to share the audio, and there are sites available on the internet where people are doing this. Kiwi is one of them, and I've listed a number of sites. It will very happily tune to the frequency you want. You can, once you're there, change frequencies, change modes, AM, FM, USB, that type of thing. And this is very useful if you want someone to be able to listen to something, for instance, a friend hear a broadcast, or you just want to, while you're traveling, listen in on a particular frequency, or if there's something that's available in a particular area that you can't receive on your home equipment.
Can check him out, nobody can control him, nothing. He absolutely leans on Russian power from Putin, and then he's an absolutely brutal president.
Okay. And this is the control panel. And again, you can pick your frequency, pick your mode. There's lots of capabilities. And of course, you can also share. And you can, each of these, there's a directory list, and you can look at the list and decide what which SDR may be able to best meet your needs, best get the signal, better antenna, that type of thing. Another thing is you can share is ATC information, right? The audio broadcast as planes are flying near your house. Again, you can listen to that on radio, but if you want to listen to a different area, you want to hear someone's plane landing, or you want to hear the president's plane flying somewhere, you certainly can. This short clip is from my receiver.
At 3000, clear for RNAV 129, Chester County, 7 Mike Romeo.
And of course, they speak their own language as well.
At 3000.
Aircraft are now required to broadcast something called ADS-B, which is short for Automatic Dependent Surveillance Broadcast in most areas of the country. And this broadcast is digital data, includes position in 3 dimensions, speed, identification information, and a lot more. It's broadcasted without encryption and around the world. The original receivers were expensive, like the SBS-1ER, which was in the $200, $250 range in 2009 when it came out. And it's about the size of a hardbound book. You can do this using a base station like the SBS-1ER or Raspberry Pi solutions. And it provides both real-time tracking without intervention of government aviation authorities and through websites' historic data. Below, there's a flight of a particular plane that flew from Pottstown, Pennsylvania to Cape May, New Jersey, November 47 to KWWD, and back. My receiver provided the tracking data to the provider several times. And you can actually see, if you look, where it has my user ID there. Okay. I picked that particular plane because it's one that I'm in a club on. So I actually fly it, and it's fun to say, hey, how come you went over my house at 3,000 feet? This is an example of the screen that I can watch the results real time. And all this is provided by a couple of little USB SDR dongles and a really good antenna. FlightAware is the example. The cost for these, you need the sticks, you need an antenna no matter what solution you use. It's a couple $100, but it's not just limited to this application. The Raspberry Pi that I have running, and you'll see it in a moment, is actually supporting feeding on multiple bands. It's a little bit hard to see, but the planes are actually moving on here. This gives you an idea about where I live. I'm about in the center. And you can see how far that my radio, simple equipment, is able to pick up at altitude. Now, there are plenty of places to share this data. FlightAware, Radar Box, ADS-B Exchange, COAA, which is Plane Plotter, Flight Radar, etc. And sharing typically gets you benefits like higher capability accounts. The standard guest account just lets you look up 7 days of history and current information on flights. The enterprise account that I get for sharing gives me multiple weeks. I think it gives me a month, maybe it's 2 months of history. It will send me alerts when planes take off or situations occur. It just gives me a lot more capability. And of course, it's part of the internet's sharing ethos. Okay? I do it because I can. This also can be in portable form, using a tablet, a cell, Raspberry Pi, and you can do it for fun, just because you're weird like me. When I'm traveling as a passenger in the back of a commercial plane, I'll carry an SDR chip, an on-the-go cable, and a small antenna, put it up against the window, and I can pick up the ADS-B data, or I can pick up audio from the over the radio. Or as a pilot, when I'm sitting in the front seat in a personal plane, for situational awareness, because then I can see the airplanes around me, even if I can't see them visually. When I'm doing that, I'm actually using something called a Stratix. And that's a Raspberry Pi-based SDR device for mobile decoding of ADS-B data. And it's powered by a 5-volt phone charger, the kind you can plug into your 12-volt socket, or a battery. And because this is pre-recorded, I can't actually show it live. I'd love to have you to be able to connect in and actually play with it, but you can't. Instead, I have to show it to you this way. The little blue triangles are other airplanes around me. The green plane is in the middle, and this is actually an aviation chart. I apologize for the quality of this, but I had to be outside to pick up the planes to be able to use this. Now, if there's a plane flying near me, I know it because it's showing up on my electronic flight book. Because this is GPS enabled, my plane will also move, so I know it's nearby, and it will actually provide alerts if a plane gets too close. I can also access the Stratix directly using the web interface built in, and here it is. It's showing the planes, and it'll actually serve up a map so that you can see what's happening. And these are moving, and it is darn near real time. Just another quick view of the actual data being provided. They're telling their location, their speed, their altitude, some information about their ADS-B, that type of thing. Setting up is actually very simple with these. You plug the USB dongle into your selected device. Again, the PC, the Mac, the tablet, the Raspberry Pi, the on-the-go cable, whatever it is you're going to use. Connect an antenna to it. Obviously, the better the antenna, the better the reception. You load the appropriate software, depending on what you're trying to do. You configure it, and you get to have fun. If you're sharing it over the internet, you should be provided with a URL and other necessary configuration information to get it to that provider or to allow other people to get to it. Now, just a quick view of my setup at home. Right. These are the SDR dongles. They're actually in a external USB hub. This is the SBS1ER, and then sitting here is the Raspberry Pi itself. This is actually in the top of a closet because that's where I have access to the attic. The antennas are in or fed through the attic. And yeah, it's a little bit ugly. One of these days, when I have some free time, I'll make it look pretty. And then this is the actual hub. Okay. This is the dongle. This is one of the 2 pluses that I showed you originally. Gives you another idea size-wise. Right there's my thumb. Right, that's for live ATC. The next one's empty. This one is picking up 1090 megahertz as part of ADS-B. This one is picking up APRS. And then the last one, 978 megahertz. The blue and the orange reddish are actually specialized for those frequencies for this purpose. Again, had a bunch of acronyms. ADS-B is the automatic direct surveillance broadcast, 2 different frequencies in the US. The aircraft are broadcasting their position. TISB is where the FAA rebroadcasts that ADS-B data to tell me traffic. So even if I don't see or hear that other aircraft, the FAA is sending me their position. Another nice feature is FISB, Flight Information Services. This is where the FAA is giving me weather and flight restriction data, for instance, where the president is, because I better not be flying over that without permission. In case you aren't aware, APRS is Automatic Packet Reporting System. It's a ham radio system, broadcasting coordinates and rebroadcasting over the air and sharing on the internet. And you can have it in your car. I do as on my Yaesu 350 FTM. It just says, I am here. DSP, digital signal processing, converting incoming signals to digital data. A to D conversion, performing the processing of that digital data and then returning to analog form for use as needed. A digital analog conversion, right? So that I can actually listen to it. Something important to discuss are ethics, right? If you want to, you can really annoy billionaires with this data, like Elon Musk. A particular individual figured out which airplane, what his tail number was, his registration, set up a little application to read the data, and then send out tweets every time every time Elon's plane was in the air. Musk wasn't happy about that. Or you could put the president at risk while he's on the way to a battle zone. They actually flew Air Force One under a, I'll call it a false, a separate registration ADS-B code, flew out of Andrews to try to prevent people from realizing the president was on board and that it was indeed Air Force One 747. But the flight profile was kind of weird. People started watching it, and there are actually pictures of the aircraft flying over England where someone has a hobby of they take pictures of airplanes in flight, and with a good lens, the 747 with its colors, its paint scheme is pretty obvious. Even if the information is legal to share, should you? Well, with an automated system like I have upstairs in my house, you don't have individual data item choices. Right? I'm providing that information, providing it to a service provider, and it can be used for good. Right? For instance, additional information in the event of a crash. The ADS-B tracking data will tell them what the plane was doing before it crashed. And the FAA does not have coverage of the whole country. Also, tracking of lost aircraft. Where was it last seen on ADS-B? This can be used for evil, like I did showed in my examples. And something important to realize is, in general, some of what you may hear may not be legal to share under FCC regulations. That's something important to consider. Yes, you may be able to listen to it, but can you tell anybody? I've provided some links so you can look at the actual information directly if you'd like. I'd like to thank the organizers. This is a great event. I've attended some of the prior ones as an attendee. So here I am speaking, or at least recorded. And, it's all about choices. Sometimes it's better to have a computer to process your radio signals. It gives you a lot more flexibility, a greater capability to change, to throw resources at it. And sometimes it's better just to use discrete components. Right? There's something about even having an old tube radio glowing and the hums and the sounds. It's really up to you. Right? And if everything's working right, we now have a question and answer session. So please feel free to ask. And thank you.
Hopefully you guys are able to hear me. I'm not certain. David's working on resolving the issue from his side, but he just wanted me to relay a message to Ray that he's used them on commercial flights as a passenger. You probably need to go and get connected to the internet that's usually on most of the planes, or you can use a device like he has where it has an antenna that would allow you to connect and pick up the signals while you're in the plane. He's dropping out real quick. He's going to come back in here in a minute. He's hoping that by restarting, everything will come through.
How about now?
Yep, you're good.
Okay. For some reason, the microphone would not unmute on my side. So yeah, this is actually the device that I've used while flying as a passenger. This is actually a little badge clip. I'm not sure how well it can be seen, but I actually clip that on the shade right next to the window, and it picks it up. I am a private pilot. I'm not a commercial airline pilot. But I will actually use that with my tablet, and no one's giving me grief. Although it's not real visible. It's not like I'm carrying around a big box and sticking it around. ADS-B uses the 1090 megahertz around the world and 978 megahertz in the U.S. In the U.S., it also will provide the services from the government, the TISB, the traffic information and the flight information, weather and that type of thing on 978. Yeah, people look at me funny. Anyway, Ray was asking if people don't look at me funny. They do look at me funny, but if I'm next to the window, they might not necessarily see what I'm doing off in that corner because I'm just sitting there with a tablet on my lap. Yeah, they might ask, well, what do you see there? And it has weirded out a few of them, and I just say, no, I'm a pilot. It's okay. But then again, I used to carry a handheld GPS on the plane just because I was curious what was outside the window. Again, I'm weird. But yeah, those are the ones that are for aviation. There's lots of aviation frequencies, audio frequencies. The best way to do it is Google the airport near you and for the frequencies, and it'll tell you the frequencies, and you can just listen to them. I am going to try to share. No, it's not going to let me. Not going to let me share my entire screen. Let's see. Well, let me share a window. All right, I think this is the right window. All right, you should be able to see a window, and hopefully it will start sharing the audio. So I hope you can hear the audio. That is tower and approach frequencies for Philadelphia for my slice of the pie of planes flying in. Now I can't pick up the tower itself because it's down in the weeds, as it were, but I can pick up the planes going overhead. And unfortunately, it's not a very busy time. Matter of fact, this is this is the planes that are flying overhead at the moment. based on the receivers that are up in my attic. Ray wrote, even amateur radio operators in South Africa are now supposed to listen to the airband. Do you mean not? Oh, well, that's interesting. I'm sorry to hear that. He did confirm not, because the airbands are kind of international, and you can hear some really interesting things. What you do is up to you, and I'm certainly not going to suggest you do anything illegal. Michael asks, do you have any perhaps common examples of things you'd hear on ADS that would be illegal to share? Well, not on ADS-B itself, because the ADS-B is that's being broadcast everywhere. But you could also listen in on other frequencies that you may hear things. You can listen in on police frequencies, for instance, railroad frequencies. In theory, you could listen in on the older style portable phones, the older style cell phones, which actually is illegal in the U.S. Certainly listen in on someone else's GMRS or that type of thing. The use of a radio for business is way down with the ease of cell, but you used to be able to listen in on tow trucks or that type of thing, or you hear of an accident and dispatch your tow truck buddy to it before anybody else could get to it. That type of thing would be illegal. You certainly can hear a lot of things on actual radio. And let me turn the microphone on. Hopefully, let me refresh it. It may have been sitting too long. All right, there's a lot of noise, but you can hear the WWV clicks in the background. Hopefully. So anything that is receivable in Arlington, Virginia, in theory, I could connect onto and listen to using this person's receiver. Okay. So anything that's out there, I can listen to. Any other questions? I showed the one dongle. These are the Nano 2s. Right? Get a good idea of the size. And inside, this one's one that broke. Inside, it's a little USB. There's a little antenna port on the end. A couple chips. There's actually a photo transistor that you can run a remote control to. I've never actually run the remote control, although with some of the kits you'll get it. Everything I'm doing from the PC. The older style, they're big like this. They come in a little kit with a little antenna. And this one, that's actually, this is the one that the remote is from. And there's it'll actually blink when, there's a little LED that'll blink when it actually receives commands. All right, if there are no other questions, then thank you for attending. Oh, Jeffrey's asking, is there an SDR that you would recommend? Well, you know, the Noon Electrics, the 2Bs and the 3s are the ones that I like. They're inexpensive and they're reasonable. Right? They're not super powerful. All right. There are ones that you can buy that are larger, that have preamplifiers, that have filters. You can get up converters if you're looking at picking up lower frequencies. It all depends on what you want to do. Again, you know, $22 to start, or like $30. All right, great way to start. And then if you find that you're really doing it, or you need to do more, you want more capability, then you can start investing the real money. I have, like I said, I have these picking up APRS data. I have specialized ones for the ADS-B in my house because vendors gave them to me. Right, the FlightAware and I think it was Flight Radar gave me the dongles because they are specialized. They have filters, they have preamps for those frequencies, and they gave them to me because I'm sharing data with them. So they get benefit, I get benefit. The Noon Electrics are good just because they're readily available. They're essentially upgrades of the RTLs, Ray. And like I said, they're available. They do sell kits for ADS-B, so you get two of these, right, or two of the version 3s, which are aluminum to dissipate the heat better. You get two antennas, one for each of the frequencies. You get cables. There were a couple other things. Oh, they will actually set them up for the software. Is that readable? Not really. All right. They will set them up for the software. Will recognize them for a particular frequency, and they'll tell you the frequency deviation. They'll measure them for you so that you can tell the software what those values are, so that they can compensate for them. That's an advantage, and they're cheap. They really are. If I was going to be sharing audio like the Kiwi SDR type stuff, yeah, I would buy a better one. All right, or maybe I'd buy one that I could up convert more for the ham radio frequencies. I'm just doing all over the place personally. Let's see, are there any other questions? All right. Is there a place we can see the information you provided in your slides today? I did upload the slides. I believe that they're going to be made available. If not, look me up on LinkedIn or Facebook, and I will make sure that they're available. Eric, do you know if they're going to have a repository for the slides? I know I uploaded them in PDF.
I'm not 100% positive about that.
Okay.
It might be something that when you go back and revisit, there'll be a button linked to the video that you'll be able to download the content if it's been uploaded.
Yeah. Like I said, I've made them available just so that you can go and get them. Amazon, Google, the information is out there. It is available. Any other questions? Very well. Thank you very much for attending. Appreciate it. It's always good to have an audience. And oh, wait a second. Ray is saying he thinks the presentations will be available for a month after the expo. So if you're going to download it, soon. And if there's nothing else, Eric, thank you very much.